So we've got a question for Spring 18 Test 1. We're supposed to do R and S on all the stereocenters in this lovely molecule. You would not have that many stereocenters on yours. They had more time than you. But let's take it from the lowest letter, E here. And the priorities go. Well, we got 4 carbons, so it's a tie all the way around. Carbon, 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 carbon. But every carbon other than the top one has more bonds to carbon. And this one has just bonds to H. So we got our number 4 established right there. And that's the 4. This is a C with 1 H and 2 C's. Most importantly, the 2 C's. This C has 3 more bonds to C. Yeah, each one of these you should treat of as like a single bond to C. So that this one here, just put a little, I don't know, a little symbol here. It breaks down to 3 bonds to C. Okay. And that's going to be our number 1 because none of the other carbons has 3 bonds to C. This one has 2 more bonds to C and 1 bond to H, and this one has only 1 more bond to C. And do you remember when we don't have to do double switches? Or when do we have to do double switches? Well, we have to do a double switch if the number 4 group's not on either a wedge or a dash. In this case, it's on a wedge, so a double switch is not necessary. Just keep in mind that when you circle 1, 2, and 3 and get the direction that is indicative of normally an S, which is counterclockwise, when the 4 is on a wedge, that is wrong. So S is wrong, so I don't know how to say that. Yes, I do. I put an S with an X through it. Is really an R. There you go. And we okay with that one? Ready to move on to F?
Yeah.
All right. F will do in blue, and it's got an H for number 4. And it's got a C with nothing but C's for a 1. It's got a C with 2 more bonds to C for a 2. And a C with only 1 more bond to C for 3. And here the 4 is already on a dash. How nice is that? That's a counterclockwise circle. And go with the light blue. 1, 2, 3. And that is a legitimate S that is correct because the 4 is already on a dash.
So, Professor,
Yes.
so basically you don't see like how long the chain would be, like connected chain to chain.
No, you go 1 atom at a time until you break the tie.
Okay, so like whichever atom has the most bonds to carbon out of the two. And not bonds to
Mm-hmm.
carbon, but like bonds to the heaviest one. Like,
Hey, if I had a carbon over here, this thing that was 3 and it had a fluorine on it, this carbon now became number 1. Do you want to know
so
why?
because the fluorine
Well,
has,
fluorine is heaviest and it's the same distance away as any of these carbons that are 2 atoms away. So when I look at just C's and H's, yeah, I can count number of bonds to C. And in this stereocenter is nothing but C's and H's all the way around. So I start from the beginning and I say there's a carbon that has 3 more bonds to carbon. 1, 2, 3. It's going to beat a carbon that only has 2 more. Why? Because the 2 tie the 2 off of this. And the third one here is an H, which loses to the third C off of this. And then this one only had 1 more bond to C, which means we broke the tie a lot earlier on that. The 1 bond to C here tied one of the bonds to C here. The second bond has to be an H now because you're out of bonds to C. An H is being compared to a bond to a C, and a C is heavier than an H.
okay.
All righty. And moving on to, let's go with green. Moving F, G. Where is G? G's down here. E, F, G. Just random order here, it looks like. We have a 1 for an O. O is heavier than C. We have a 4 for an H. Now, which of these CH2s is going to be the winner? Well, they're both CH2s with one more bond to C. So they're tied all the way up to this position for this group and this position for this group. And clearly this one has only one more bond to C, and this one has 3 more bonds to C. So the C's are going to beat the H's up here on 3. And that one, we're lucky again. We can just connect 1, 2, and 3. Counterclockwise is correct. It's an S. And then moving on to H. Finally, a double switch is going to be in order for H. Let's go hot pink. We have a 4 for our H off of stereocenter H. We have, it's tricky for 1 and 2. One of those has got to be 1 or 2. And it's because they have 2 more bonds to C, both of them. And this one down here has only 1 more bond to C. So this next bond is an H compared to one of these C's. So let's go with the 3 and then break the tricky little tie. Might be a little bit of work. We'll see. C, well, where are we? We're here. Sorry, we're doing H. So we're comparing this carbon here to this carbon here. So let's put a little pink dot on that one and that one. Trying to figure out which one is the higher priority. Well, this one goes to a C with nothing but bonds to C. And this one also goes to a C with nothing but bonds to C. So that portion's still tied. Now let's go and look at the other C. This C is a CH2, and off of here is another CH2. Oh, wow. This is a nasty little stereocenter. I confess it's nasty. So we're tied up to the CH2 next to the dot. So now we got to go from here and ask ourselves, well, when we go here and when we go here, aren't they a further distance away than going back to our original comparison of nothing but bonds to C? And yeah. So here a C and here a C. We were tied because they had 2 more bonds to C and 1 more bond to H, right? And then we went here and here. We said they're still tied, same distance away, because there's C with nothing but bonds to C and C with nothing but bonds to C. But over here, I see a winner off of here. This C with nothing but bonds to C goes to another C with nothing but bonds to C. Can you say the same thing about this C with nothing but bonds to C? And the answer is no, because either direction, you get a C with a bond to H, which means the H is going to lose to the C with nothing but bonds to C. So that gives this guy the number 1. And sometimes it's wise to just move on and realize we're talking about questions where the answer is a 50-50 proposition to start with. So I'm losing track of where the heck I was if I'm talking here. I didn't even put the 1 in the right spot, did I? This is where it starts. So you got to number that. And this was the 2. And like I'm saying, if I'm on a test and I see this and it's a tricky little bugger, as sometimes they are, I'm just going to put a guess in here. You got a 50-50 shot. I think that's I hate to say it as a teacher, I think that's better management of your time than actually doing all that work I just did and waving my hands around a lot. I don't know. What do you think?
But
Plus this thing needs a double switch now. It's a little nightmare stereocenter. And don't blame me. I took this as a real molecule. I just got it from nature, people. I didn't deviously come up with this thing to come up with a nasty little stereocenter. That was not my intention. But you had a question. I'm sorry.
So you grade the 1, 2, 3, 4, the order.
No, I grade your answer, and that's
it. You just grade what's in the box.
That's it. Yeah. And on your test, you'll notice I gave the same advice during some session to the students in the previous test, the one you're supposed to study like fall 20. I gave them the same advice, But, you know, I want you to do some thinking about it. So there's a qualifier on that one. It says, if you guess every answer R, there's a penalty for that. That's on top of just not getting right or wrong. Because, you know, yeah, you got you got a good chance of getting some points there, right? If you're guessing them all the same. And I do want to see who knows these things. So I have to be able to evaluate that. So on this one, since we're here, we've got to do a double switch. We're talking about H, and we'll do the H over here. And double switches aren't bad. That's not something that's going to force you to guess. You copy the tetrahedron. Notice I'm not moving any of the bonds. That's what H looks like. Find the 4, move it to the position where the dash is down there. That was where the 3 used to be. You just switch the 3 with the 4. That's a single switch. Don't stop there. You've got to switch the other 2 now to get the same stereocenter that you started with. So 2 is now on the left, and 1 is here, and it's R. And there we go. And we're moving on to I. We'll use, we can go back to red now. And I's got a 4 for an H. It's got a C with nothing but bonds to C here for 1. And it's got a C with 1 H and 2 more bonds to C. Well, the second bond to C is going to beat one of these H's off of here because the first bond to C here ties. And I didn't put the 2 in the right spot, did I? Wait, no, I'm figuring out that this was the 2. And this is the 3. And 1, 2, 3 is it's the correct answer because 4 is already on a dash, and that would be an S. And let's go with a purple for J. J. 4 for H. 1 for C with nothing but bonds to C. 2 for C with 2 more bonds to C. And 3 for C with only 1 more bond to C. And 1, 2, 3 is R. Clockwise. And K, we'll go with green. 4 is on a wedge. That's just as good as a dash. Just remember when you do your circle, it's the wrong answer. 3 is a C with 3 bonds to H. So most of the stereocenters on this molecule were not too bad. This C has 2 more bonds to C, which is better than... Oh, why did I do that? I didn't do what I said. This is the... Oh, 1 more control Z. This was the C with 2 more bonds to C. This was the C with only 1 more bond to C. And this one, the wrong answer, I'm going to write not S, therefore R. And did we do all of them? We did. Control, save. All right, and before we render this in a video, do you have any questions about this one before we go to another one after a little break?
No, this makes sense. Okay.
All right, so we'll stop. This one shouldn't take too long. I'll come right back, maybe 5 minutes.